Another radian measure question. Let's just go over the background a little here. This is our compass. It goes north, south, west, east. Okay. They said that the needle of the compass, which is this black line here, is pointing 4 radians away from our east measurement on the compass. They also said that the compass needle is 4.2 centimeters below, or the tip of the needle below the west measurement of the compass. Okay, so that's how we know where this is in relation to the entire circle. Now, technically, this is a right angle triangle, and they want to know how long this compass needle is. That's our goal here, is to find out how long it is, or in other words, is essentially what the coordinate of the tip is. The coordinate of the tip will tell us quite a bit of information. Coordinate of the tip, we already have the y, and if we figure out the x, we can then use Pythagoras theorem to figure out how long this is. Okay, so what that means is we need this small angle here. There's several ways we can do this. We keep this in radians, we can put this into degrees. Now we know this is considered pi, or 1 pi, which is 3.14 radians, or it could be known as 180 degrees. Okay, we also know that down here is considered 3 over 2 pi, so 1.5, or 270 degrees. Okay, so we know that our angle starting from east is going to be between 180 and 270, or between 1 pi and 3 over 2 pi. Okay, so let's decide how we're going to go about this. Maybe we could even try in both measurements. Okay, we know that it's 4 radians, and this is how to convert to degrees, our radian answer. Okay, so if we want to figure it out in degrees, degrees is equal to the radians times 180, so 4 times 180 divided by pi. And what did you get when you did this? 229 degrees. Okay, that makes sense, right? We're divided by pi here. Now, another way we could, can we convert this to 180? Okay, if we were to flip this around just to get the idea of what it would be with pi in terms of a fraction or a decimal to pi, because we are used to working with those, we now know this is 229. So in other words, 229 is equal to, let's say we wanted to put into our radians with pi. Well, we still have 180 divided by pi. Well, we would bring pi over, and then 180 would become divided by. I'm kind of doing this in 2 steps. So in other words, we get 229 pi divide 180. Well, let's just reduce that decimal in front of pi to figure out what our radians are in pi. Does that step make sense?
Yeah.
Okay, so what's 229 divided by 180? 1 point something.
1.27.
1.27 pi. Okay, is also our radians. Okay, so we've got 2 measurements here. Okay, and let's try to go about this using 2 measurements. So the full distance of this is either 229 degrees or 1.27, did we say?
1.27.
27 pi. Okay, great. If we know this is, there's 2 ways we can do this. I can solve this very quickly with the pi measurement. We know that this here is 1 pi up to this point. Okay, so how much past that did we go if it's 1.27 pi? If this is 1, so the starting point's 1, and then to here is 1.27 pi, what's the difference in here? How much farther did we move this angle? 0.27. So we know that that is 0.27 pi, that little angle in there. Okay. The other way we can do it is we can take our 229 and subtract 180. Does that make sense also? Okay. So if we were to do that, 229 subtract 180, what do we get?
49.
49. So in other words, that could also be 49 degrees. So we got an angle and we got a side measurement. Okay, we can use, we could do about this 2 ways. The long way would to essentially be to find out this here and then use Pythagoras theorem. Or because this is a right angle triangle, let's just actually use our SOHCAHTOA to figure this out. Okay, so let's scroll down. We have 0.27 and 49 degrees as our measurements. So I'm going to recreate the triangle just down here in a different manner though. Okay, I'm just going to put it, whoops, I don't want that line. I'm just going to put it, actually no, just to reference it a little better, we'll draw it the same way it's drawn down there. Okay, and we'll change the color to the one we want. Thank you. Okay, so here's our little triangle. This is we've made our side notes now. This can be known as 49 degrees, or it could be known as 0.27 pi in terms of a rotation, this angle here. We know that this distance is 4.2 centimeters, and we need to find out this we'll call x. Okay, it's a right angle triangle, so using our trig, our primary trig ratios, how can we set this up? Which trig ratio would we use? We have the, what's that considered, that side?
The
Opposite and the hypotenuse. So what do we got? We need sine, what?
X.
Are we looking for the angle? This part here is always the angle, right? We already have the angle measurements. So what is the angle measurement? It's sine 49. Or, I'll do the other one in blue, it's sine 0.27 pi, okay, is equal to, what's the opposite side?
4.2.
4.2 over
X.
hypotenuse is our x. So it equals 4.2 over hypotenuse is x, okay? So in this one we're working in our degrees, okay, and this one is our radians over here. So all that's left now is to really solve these two. It's the same answer, just using a different method for each, okay? So we'll quickly go through the algebra here. I need to move this x over, so this will become x times sine 49 is equal to 4.2. I need to get x by itself, so it becomes x is equal to 4.2 divided by sine 49. Does that make sense? Okay. What would you get in terms of a degree measurement?
Wait, just sine 49?
Yeah, so 4.2 divided by sine 49. And in the meantime, I'll move this triangle.
A negative number. Is that okay?
Well, yeah, let's think about it, right? If our cast system here.
Oh, yeah. Sine is negative.
Okay, yeah, but actually, no, this sine 49, because we've changed it, we're not using obtuse angles, we've changed it to an acute angle, it shouldn't actually go into a negative. So you should try that again. Sine 49 should be positive.
Oh, should I do it separate?
You're in radians right now. You need to change your calculator to degrees, because that question was in degrees. Always make sure you know what you're working in, right? So because we were working in degrees, you got to change it back to degrees, and then the second one will have to work in radians. Now I'm going to move this one over, so this becomes x's times sine 0.27 pi equals 4.2.
Yeah, now it's 5.56.
5.56 as a measurement. 5.56. Okay, that makes sense. Now in our other one, let's see if we can't do that too. 4.2. This one's in our radians here. Sine 0.27 pi. What would you get if we did this in radians? 4.2 divided by sine 0.27 pi.
5.5.
5.5, right on?
9.
9? Okay, so because there's a bit of rounding here and there, we got roughly the same measurement for the two of them, right? So whether we worked in our radians in blue or degrees in black, we still got a measurement of 5.5, we'll round it to, or you could round it actually to 5.6 to be a little more accurate, I guess. 5.6 centimeters, which makes sense. It's the hypotenuse of this triangle, and if the height's 4.2, we know the hypotenuse has to be longer, right? So this is a logical answer. We've got something that makes sense here.